Obligatory cough. Okay, good morning. Still got some morning left today. Welcome to the Build Conference talk on how to create cutting-edge games for tablets. My name is Chaz Boyd. I've been working at Microsoft on DirectX since DX3. So it's really exciting to see this opportunity now for all of the DirectX technologies to end up in situations that are brand new opportunities for us all. Okay, the message that we're communicating here at the conference today is that the PC is evolving and expanding in the terms of the number of shapes and sizes that it can exist at and the number of situations that people can use their PCs at. You can use them at the desktop, you can use them in a meeting taking notes, you can also use them in a, sitting on your living room couch with in a more consumption type mode. I found that to be a new way that I can use my PC that I was really never able to use before. And the interesting thing about that is that if you're a game developer, now this represents an opportunity for you to take the PC game technology that you already understand and are potentially even leveraging on the PC today and move that technology more broadly into the lower power devices, the higher battery life devices, and the ones that are likely to be on the living room coffee table. And that's really what the opportunity is for us all, is to capture the time that the user is spending there, the eyeball minutes it's called in the industry, that are now previously would not have been accessible to a PC game developer. So in what we've done over the past couple product cycles now is create a platform that's specifically designed to enable applications to span the full range of PC types like this and bring that same experience to the user no matter which of those situations that they happen to be in. And they can transition instantly. So what we're going to do is we're going to show you some of those technologies and how you can use them to help grow the number of eyeball minutes that your game can actually use, the customer can actually use your game. The interesting thing that we're seeing is now that people have got really lightweight PCs, they're more likely to be using them on the bus. They're more likely to be using them, at your bedstand when you read at night, and you may also have them, of course, on the coffee table. And that's one of the interesting scenarios in the living room is that there's typically going to be multiple people in the living room, and you may have opportunities to do multiplayer experiences there as well. This is a synergistic thing where as the applications are moving there and the hardware is moving there, the developers are moving there. It's it's a circle where everyone's contributing to everybody else's ability to move into that space. And so to show that we're encouraging this type of investment, we've implemented a range of technologies that are designed to target this range of innovation. The situation right now is that we've seen a lot of the early titles show up in Windows 8 have been the kind that are pretty easy to create because it's been so early. But over time, what we're expecting is to see more and more applications that come from a higher range of production values and just scale of product that will bring a very consistent level of experience across all the different shapes and sizes of PCs. And so to make that even easier, we continue to invest in this. And some of the stuff I'm going to be talking about today are the pieces of that puzzle that fit everything together into a single unified platform that spans from the new sort of input mechanisms, for example, that tablets have, like touch and accelerometer, but at the same time bring down from the PC, the gamer rig, an SLI configuration, that it's got the latest Direct3D11 chips. Those are coming into the tablets now, as you've seen with Surface Pro, and then future tablets are becoming more advanced in their DirectX technology. So on the graphics side, for example, we're very consistent across all the different configurations. The other advantage of this new platform is that with the store policies we've got, Anybody can self-publish. That should make it easier to get your product out there. And then we believe that by the time you've seen all of the APIs that we're going to be talking about today, you will understand that we are investing in making it as easy as possible for you to create experiences that do span all the possible ranges of PCs. And we've even gone to the trouble of actually, building our own silicon that demonstrates how this works. Here's a device that has the tablet scenario pretty well nailed. It's got nice touch, but it's also got a DX11 graphics chip in it that can run the latest PC games that are out there today. And this is just the obligatory comment that we'd like to remind people of, is that there's even people in the games business, like the Penny Arcade guys, said some very positive things about this product. Okay, so talk a little bit about the platform. Our objective is to make sure that the new API set that's based on the Windows runtime has all of the bits and pieces in it that you would ever need to create a game. And so what we did in the process of designing the API set for Windows 8 was we went through all of the APIs that we had and make sure that we chose the ones that are most important to games to focus on for this new API model. And so on the graphics side, we brought across our DirectX. We've got the Media Foundation technologies that you use for cutscenes and sound effects, for example. The input technologies we brought across were things like Xinput, which is the same one that's been used on the console and the PC for quite a while. There's a fair number of controllers out there that are already compatible with that standard. On the audio side, we have the Xaudio 2 Games API, which is really optimized for the kind of low latency sound effects that you need in a game. And then we're also investing in improving the connectivity story, like we just saw in the previous talk. Nice demonstration of multiplayer set up over Wi-Fi Direct protocol, which is a very ad hoc, much more convenient, much more spontaneous way for people to connect to each other, such as they would at a social situation, or if you've just got kids in the back seat and they want to play against each other, they can do that even if you're in the car and there's no Wi-Fi anywhere near. And then, of course, our tool story is continuing to be a source of investment. One of our examples of how we've created an API that spans the range of PCs is this concept of the pointer point API, which is a unifying abstraction that allows you to write the same code, and yet the user can use a stylus or a touch finger or a mouse pointer, and they're happy because your application just has to have that same code path work. You can always go and ask at some level down in the stack if you need to know the explicit difference between a finger and a stylus. You can query that information as well, but it just means that by default, if you write code using these new APIs, your application is going to span this range of devices. Okay, so now on the graphics side, we're very proud of our Direct3D technology. It's really the foundation of the most cutting-edge games that are out there in the world today. Some of the very popular titles that have earned, hundreds of millions of dollars. And that technology is available, again, in a way that spans all the different devices on our new Games and Windows Store app platform. Here's a couple examples of the types of production values that you can see. The upper right is the Halo Spartan Assault, which there was a talk on yesterday afternoon, and then the lower left is Reckless Racing. And these are games where the developers are not really having to hold back on the quality of graphics that they deliver in these applications. It doesn't just have to be a sprite game. Okay, so in Windows 8.1, we're continuing to invest along these lines, and we've added some additional components. Specifically, we've incremented some of the interfaces in our Direct3D to add some new functionality, which we'll talk about in a bit. And then we've also optimized the store quite a bit with a new visual experience and new ease of detection. And then also we'll have some significant improvements there in the way that applications are actually delivered and installed to your machine. Also, the Wi-Fi Direct technology is new, which we just talked about in the last talk about an hour ago. And then there's also some solutions in the Azure space, which I'm sure a lot of you guys are aware of, that would be very useful if you're trying to create applications that span multiple users or multiple times in their use. Okay, so first we're going to start with the graphics component. And there, I think it is pretty obvious that Direct3D 11 is the latest graphics API. It's the most advanced that exists right now with the technology that we've put in this product. And the nice thing is that all of these Windows Store applications can run that API. We've enabled the API to span within that same API multiple generations of silicon, which is kind of the cool thing about that. And the way that works is that, Direct3D has always had the ability to span multiple vendors' hardware, so that each generation of silicon, whether it's coming from Intel, AMD, NVIDIA, they look very consistent to the developer. They can write a single code path and span those 3 vendors. But the point is we still want those vendors to innovate in consecutive generations. They need to move forward because there is always new features that the consumer wants to see in terms of visual impact on their application. So our model for that has been to organize the features of the hardware into these groups. And this is what we shipped effectively in DX9. This is the kind of technology that's in the Xbox 360. And then, the next generation of silicon after that, we added, the industry was organized around this set of features for DirectX 10. And then after that, we added DirectX 11. And then, in fact, these last few on the DirectX 11 on the right-hand column are those that we added for just Windows 8.1. And those are the ones that result, again, in this API being the most advanced available right now. Specifically, the tile resources is something that we're very proud of. We worked on that for many years, and we've achieved a significant amount of industry alignment around that feature to the point that you can install drivers from multiple vendors today, AMD and NVIDIA, and just, when you get home, those drivers should even be on the web. And then get access to, a new capability that hardware has really never had as any graphics API capability before. I wanted to give you guys a rough idea of what the ecosystem looks like in terms of the number of different machines out there. On the left-hand side, we're showing a typical sort of distribution among gamers. I didn't really put a lot of significant digits in this diagram. It's just a rough idea to tell you that there is still a few DX9 chips out there on the desktop. But as we move into the tablet space, where the living room scenario is and the more broad usage of the PC is, then there's a significant fraction of those devices are DX9. So as a developer, you really need to keep in mind all 3 of these if you want to maximize your target audience. It's possible for you to choose a subset of those APIs when you ship your application and just focus on a few of those, but you need to understand what the sort of trade-off is in terms of the impact on the number of users that can use your machine. So the way we do this in the API is very simple. When you write your code, you'd say, okay, do I want to use some DX9 features or some 10 features and 11 features? And then you send us that list of the features that you want to use in this input array called the feature levels that you support. And when you initialize the D3D API, we take that list and we go through it and find which is the one that is the best match for the hardware that you're on, and we turn that value as the feature level. And then you know what code path to use for the rest of that application. And so in that way, the API itself allows you to use a single set of APIs, a single syntax, but be able to explicitly turn on and off individual features based on the generation of silicon that your hardware is on. Okay, so this is the plug for the new feature that we just put in. This is a fundamental new thing. What we do in DirectX is we work to make sure that the hardware that's there is accessible to the developer. We want the developers to have direct access to the functionality that's in the hardware. And traditionally there's been abstraction layers that have been put in place, but our objective is to allow them to tunnel directly into the hardware and expose each capability of the chip to the programmer's will. And really what we've done in this case is we've exposed the GPU hardware page table to the programmer through a syntax that lets them actually modify the contents of that page table according to their needs. And the really interesting thing about the page table is that it allows the programmer to effectively spoof the GPU into thinking that memory is in different places from where it really is. And that's a very powerful mechanism that we should see some really spectacular content come out when people start exploiting that. And for example, we actually showed some demos in the keynote of the Graphine product where they have some middleware that's built on top of this technology that helps you incorporate it into your application even more easily, because they include an art processing pipeline and some file formats and some additional components that make it very easy to incorporate into an application. Again, the sort of net of this is that with this type of technology, we're already seeing cases where we can deal with several gigabyte texture databases and still only consume about 16 to 100 megabytes of working set. So you get about an order of magnitude to 2 orders of magnitude savings in the working set as far as what the GPU is there. Because we're using this spoofing idea, we're spoofing the GPU into thinking that it's dealing with a several gigabyte data set, but we're actually only giving it 16 meg. So it's a very powerful technique. And as the hardware ecosystem runs, we will see that type of technique become available even in your living room, even on your consumption device. Okay, so the applications that we've seen for it today so far have been things like shadow maps, which we've demoed, and then terrain. Another scenario that's really interesting is the fact that when you've got any kind of a 3D environment, you need to have a skybox. It turns out that the resolutions of those can be very important to have a high resolution, especially if someone in your game has a telescopic sight or something where they can zoom in on a very narrow range, then you need to have a high resolution there. Another application for this is to be able to have explicit control of an atlas type technology where you keep multiple textures in the same texture, and this allows you to manage the residency of that large texture only to the level of the pages that you're actually using. For example, if you've got an image, right now our API enables people to load a 16K by 16K image. It's just that most graphics cards really don't support the memory to be able to actually physically do that in a lot of cases. So that corresponds to like a 256 megapixel image, but with this ability to not map all the memory at once, you end up having to only allocate, like we said, 100 megabytes or so. And then other applications like a Bing Maps type giant image database is another interesting application. Matt's already given the talk on this yesterday. Matt Sandy. Okay, so we've got a graphics API that spans all of these devices, but there is a significant performance variation across these devices. How can I make sure that my cutting edge game technology is going to work on the lightweight machines? And our recommendation there is that, you're just going to have to be careful. It's really one of the things that shows a developer is really good is when they're able to get good performance. Now, we've got a lot of tools out there that help you analyze what's happening. I think the Spartan Assault guys' talk yesterday was a really good one on how to do that in a practical way. One of the challenges right now, for example, is that even sprite games can often have performance challenges because the resolutions of these tablets are so high compared to a typical desktop PC. The performance of the system may be less because it's lighter and longer battery life, but the panel resolution may be higher than a desktop PC. And so what we recommend there for these types of applications is to basically minimize the number of cases when you're drawing the same pixel with something else on top of it so you'll never see what was behind. It's actually worth your while to, for example, take some of your objects and make them out of little triangles that you can take some of the triangles out and then not have to draw them if you know they're going to be behind something else. That's, it may seem like you're doing more complexity because of the triangles being there, but in actual fact, the effort to process the triangles is pretty minimal compared to the total number of pixels that you can save. And pixels are the challenge on these high-resolution monitors. Also, in the 3D space, we're seeing cases where you really want to have sophisticated, high-quality shaders in your 3D game, which means several hundred instruction shaders or 50 to 100 instruction shaders. And those can be a challenge on a lightweight device. So what we're enabling with this, one of the new features of Direct3D this time, is the ability to have you render your 3D content at a lower resolution, which means that now I've now got more energy to spend on each pixel because I have less pixels. And then scale that three-dimensional scene back up, and then because of this overlay capability, actually have all of the text and symbology and crosshairs and cursors be rendered at the actual native resolution. And that turns out to be a very visually consistent model. It's been used on the consoles for a while. It's been used in some of our benchmarks. And in the past, it's had to use another pass from the GPU to do that scaling of your 3D content back up once it was done rendering. But with the 8.1 functionality, that last scaling pass is done in hardware, which saves you, a significant fraction of your frame time. Yep. So the talk on that was part of the What's New in Direct3D talk, and if you didn't see that, you can go back and look at the video. I've got a few slides on it in this talk coming up. Okay, one more recommendation around performance that I'd like to point out is that what we see with the application developers that are taking content from a high-end scenario like a PC game and moving it into these devices, the ones that are using the lowest level language have the easiest time with that transition. So applications that are written in HTML and JavaScript, they can even do some real-time animation if you're on a desktop. But when you get down to a lightweight convertible or so, then the frame rate starts to be impacted. C#, similar challenges can happen. The ones, I'm just saying, the ones that we've seen people have the easiest time porting to these new devices in the living room and so on have been the ones who have been using C++. Now, C++, we've done a lot of work in that language. We've done a lot of work in the tool set. We've added these CX extensions whose objective is to make it so that memory allocation is much closer to the way it is in an automated garbage collection system. It's just using reference counting instead of garbage collection, but the point is you don't have to malloc anything or free it explicitly. And then the other thing we've done is all the sample code that we wrote for Windows 8 and Windows 8.1, especially Windows 8 at least, is modeled after the syntax of the XNA architecture. So if you've got an understanding of XNA or you've written some XNA code, it should be pretty simple to figure out how to do that in C++. Okay, now another challenge that we run into on the PC applications is that a cutting-edge PC application today that you would download off of a gaming service is typically 6 gigabytes, and games that come on the consoles, on the 360 for example, on a double-layer DVD are over 8 gigabytes. And in Windows 8, our store maximum installation size wasn't really able to support that. If you're talking a Blu-ray disc, some of these games are 25 gigabytes. If you're talking an MMO, I think World of Warcraft is over 32 gigabytes right now. So that's something that can be a little bit of a challenge if your distribution system can't handle that. And like I said, in Windows 8, we were restricted to 2 gigabytes per processor type. So you could target the ARM CPU or the x86 CPU binary or an x64 binary, but the total amount that you could install on any one user's machine was 2 gigabytes. And that was a major challenge for a lot of the PC game developers and console game developers that wanted to come to the platform. So in Windows 8.1, we actually just changed that. So if it should just be a case where if you now have more assets and they put you over the 2 gig limit and you hit F5 on an 8.1 app, it should just work. So if you have an 8 gigabyte application, you should be fine. Now, one of the things that we did that makes it even easier is we have this concept of an application bundle, which helps you make your single submission into a single block like this. And you can see that it's approximately 25 gigabytes to store all those three things. But then we were thinking, we can do better than this. The thing that you may understand here is that I've got these 3 8 gigabyte packages that I need to upload of my game, one for each processor type, but my audio doesn't need to be different between my ARM machine and my x86 machine. My 3D textures don't need to be different necessarily. So what we did is we said, okay, how can we be more efficient here? How can we actually allow our operating system to deliver the bits in the most efficient way possible? And the reason this is a challenge is because, for example, in some cases you may have a person has a DX9 card in their machine, and that requires some certain types of texture formats. But another developer may have a DX11 card in their machine, and that has some additional types of pixel formats that actually look better. They actually have higher image quality for the same compression level, for example. And that makes the developer is caught in this dilemma where they need to decide between using DirectX 9 textures, even for people like on the Surface Pro who have DX11 devices, and then the DX11 user really doesn't get the full benefit of the machine that they paid for, or they have to ship both DX9 and DX11 textures. But the problem with that is with the current model, the person who has a DX9 machine has to wait for those DX11 textures to install. They have to take it on their network bill or their 3G bill, and they have to those are going to consume hard drive space on their very high performance, potentially expensive SSD that they don't necessarily want to spend a gigabyte of space on something that they can't actually display because their graphics chip can't show it. So our question, our answer is to this problem is we actually modified the way that the app bundle works in 8.1. And this is designed specifically to solve this dilemma that the developer has. So what we've done is you can now organize the contents inside that app bundle along different lines than you could. It used to be you could only organize it along the processor type. Now you can take your assets and organize them into separate chunks called resource packs within that bundle. And each one of them can contain, for example, I can put my DX9 textures in a resource pack, and then that resource pack will be installed on every user's machine who has a DX9 machine. I can create another resource pack that's got my DX10 textures in that, and that will go to the users who have DX10 machines. And 11 will go to the 11 machines. And that means that it solves the dilemma. The DX9 user doesn't have to wait for DX10 and 11 textures to download. And the DX11 user who has a machine that's capable of that will just get them. Turns out that we have a similar model that can be used for user interface elements. In many cases, you may decide to organize your symbology and assets and art and fonts in a way that's based on the DPI setting for that monitor. And so the store can focus on the user's machine that they've got and allocate the right elements for that device. And so we've got the 3 different settings, like you may if you've submitted an application, you've got to create a live tile background for all 3 different DPIs. Then you can keep them in separate components like this, and the user who doesn't have that particular machine doesn't have to wait for those bits. So let's go through an example here. If I've got all of these components like this that I can upload up to 25 gigabytes, the same as before, but now each individual user can even get more than 8 gigabytes if they want, depending on how you factor this. So if I'm on, say, a Surface RT, it's an ARM-based CPU, so it's going to get the ARM binaries. That could be as few as 5 megabytes. It's a DX9 device, so it's going to get the DX9 texture pack, and it defaults at 1366 resolution to getting the 1.0 DPI setting, and so those UI elements will be the ones that get installed. And so even though you've created a set of assets that can span all the different PCs out there, the user of this particular device only has to get the data that they really need. So let's do another example, say a Surface Pro. There's a case where the product supports a different set of hardware functionality, and so the user gets a different set of bits. They get an x64 binary, for example, because we run that OS at 64-bit. They get the DX9 textures just because we always want to make sure that the default is there, but then they also get the DX11 textures installed. And this is a case where effectively the Windows OS, Windows Update technology, the same technology that we use to update our OS every Tuesday, is available to you as developers to specifically target your content at the users and focus the correct solution at the machine that they have. So let's go through a little bit about how this works. The way we recommend people to do it, you don't necessarily have to do this, is to just keep your assets for each feature level in a separate folder as part of your project. The packager, when you go and build the package that uploads it to the store, will tag them all with the assets that they're keyed with based on the name of that folder. And then at deployment time, the installer checks the machine, sees what properties of the machine are, and downloads the corresponding bits at install time. So you can end up with, depending on how you organize things, well over 8 gigabytes on an end user's machine. And I did want to point out, yes, we always make sure that the default for each of those is always included, so that, you know, language is another parameter. If you've got, for example, game voiceover tracks that you have localized into French and Spanish and German and English, you can have those bits only end up on each user's machine, and the person who is speaking English doesn't have to wait for the Japanese audio files to download, for example. So that's the third setting, which I didn't show in the diagram. And so here's an example of the file structure that we use in some of our sample projects to do this. Again, the folder name is used by the operating system, or the packager, to actually, the automated packager. If you use a command line, you can override that. And then we built corresponding filters in our project view and Visual Studio just to keep organized, and we have different textures that are stored with different pixel formats depending on the feature level of the silicon that they're targeted at. And then the other thing to remember is you need to enable package bundles to make sure that you get this new bundle fit capability when you set up your project. And then this is an example of, we opened up the package file that is basically contains all your application. If you rename your .apex package to .zip, you can open it up in the shell and see what's inside. There's some header information, but the key thing is these are the 3 different processor binaries. Those all contain the DX9 bits, again, so we made sure the default data is always there. There's a lot of times the user on a DX11 machine will want to switch back to DX9 assets. Maybe they need a particular, they want to try a different performance or check to see if the graphics quality is as good. Reviewers like to do those kinds of comparisons. And then these are the additional DX10 and DX11 app packages, which will only be installed on machines that actually have that capability. Now, as the API, this is pretty much the only line of code you have to write, is you need to specify in your application which folder you want to run out of. And the way we recommend that, the syntax for that is just a quoted string that tells the resource loaders where to, what folder to pull those out of. And we recommend that you set that character string based on the D3D API that you use to create the device. So when you find out what feature level your hardware is and what it's going to be running at, you set the string to match, and then you should be fine. So it's a very, very small number of actual lines of code you have to put in. Okay, so the summary of all this is we looked at the technology that we had in the Windows installers and said, how can we make this help people target the individual machines that are out there with their products, and how can we optimize that? And really that's what it amounts to being, delivering a capability for you, which is allowing you to tailor your application content to the particular machine that each user has. And the nice thing about their perspective is that today when a user goes to the store, they have to look at the fine print on the side of the box and say, this requires DX9 card, 11 card, whatever, and if they take it home and they didn't read the fine print and it doesn't work, this completely solves that problem. We guarantee that, based on the operating system knowledge of the feature set of the machine, that the right person gets the right bits, and as long as you provided a solution for every user, they will get it. Okay, another area that is something to keep an eye on when you're transitioning your application from a cutting-edge, high-end device to the more broadly usable devices is the controls. And so there's some good examples out there of developers doing this because of the APIs that we've already put in place in Windows 8. For example, the Halo Spartan Assault guys showed yesterday, and they have support in their product for simultaneously the mouse and keyboard model that you would be using if you're sitting at a desk or using a laptop with a mouse, but they've also got a touchpad capability as well, so that when you're in consumption mode and you're leaning back on your couch, you don't have a mouse there, you don't have a keyboard, you can play the game. And that's what it's all about. That's how we get applications that allow the user to play that game no matter where they are. And one of the tricks to doing this that some of our samples do is we just leave all of these input models running all the time. So if there's a touch event, we process it. If there's a keyboard event, we process it. You don't have to make the user go out to a menu and switch between this mode and that mode and back and forth. In most cases, a lot of these games can just work if their user interfaces are simple enough. I just wanted to show you guys an example of that on the demo here, which is Reckless Racing. So can we, Bob, can get some audio here? Okay, so this is my normal work laptop. This is my one I take notes on in meetings all day. And I can start a game, and I'm playing on the keyboard. I'm that blue truck, which is the one that's driven by a crazy man. I didn't switch. The audio, we worked hard on the audio. Okay, so there's the truck. I'll try and go upstream. That always makes people popular. These things don't really handle that well when they're several tons. Anyway, the point is, when I'm now in my living room and I'm doing, I don't have a keyboard present, or if I'm actually using this device, when I'm using this device to read the web, I just sit there and use my thumbs. And strangely enough, this application actually lets you steer. You can see those controls that come up on the screen, and you can steer the application just with your thumbs too. So this is an example of, almost a hybrid application where I'm going to quit that. You can take down the audio, where the application is able to accept all these inputs simultaneously. I didn't have to go to another menu to switch from touch mode to keyboard mode. And this particular application happens to also work really well with Game Controller. I forgot to plug it in, but that works too. And this is the kind of thing where we don't need to make users switch from the mental model of a desktop to the mental model of something else. It can all be done dynamically on the fly. Okay, now the other interesting aspect of these new devices is that, yes, they do have higher resolutions, and they have smaller inches in terms of the diagonal, and that's what makes them more portable. That makes them light enough to hold on your lap or carry into the living room or keep by the side of your bed. And you guys now have a device that you received quite recently that goes down to the 8-inch diagonal size, and then of course PCs have always gone up. So that's a huge range of different resolutions. And corresponding to those, depending on the resolution of the panel, you get different dots per inch settings. So in the Windows 8 API set, we have a set of APIs that let you manage that resolution by organizing them into these three groups, 1.0, 1.4, and 1.8x. So if you're on the Surface Pro, for example, is the second tier 1.4x, does 1080p in a 10-inch diagonal, and you can check to see what your DPI is and use specifically different assets. What it means is that you can author higher quality text or higher quality icons for those higher DPI panels. Let's see. The thing I wanted to point out is on the desktop, we've actually added in 8.1 a new resolution that is 2x, so that we're continuing to invest in managing these different resolutions. And what that means is even on a device that is very high resolution panel with a very small diagonal, you'll still be able to switch back to your productivity applications when you want to. And the other thing to keep in mind, though, is that the performance that you require for a 3D game goes up as these panels, and it's one of these performance curves that's quadratic, right? As each number of pixels goes in each direction, the number of pixels that you actually render is the square of that resolution, really. So we see, for example, the Surface RT has a 1 megapixel panel. The Surface Pro has a 2 megapixel panel, which is, takes twice as long to draw. And then as those panel resolutions get up, it's pretty easy to get to 4 to 8 times as much performance as you would require for just running on a Surface RT. So again, our fix there is we put specific support in the operating system to enable the hardware to solve this problem, which is allow your application to render at a lower resolution, and the 3D component at least, and then have the hardware scale it back up. And because we can compose the 2D content on later, we can preserve the quality of that because you can render it at native resolution in a separate secondary swap chain overlay. And this is just the diagram. This was in Bennett's talk yesterday. For example, you can see there the 3D swap chain you render at 720p is commonly done on consoles today, for example. And then your 2D art elements can be at 1080p, and I'll end up on a nice 1080p TV at the end, or monitor, or display. Yeah, this is a 1080p laptop I have. And it's very simple. You have one API call to create the swap chain for the main plane, and then if you've got overlays, you create the second swap chain for your secondary plane and render your 2D content into that. And the nice thing about that is that overlay plane can be updated completely asynchronously from your main. You may run your main game. A lot of people will take their main 3D content and run at a slightly lower resolution so that they can get a higher frame rate, guarantee 60 hertz of that. But the overlay plane, you probably only need to update when the score changes or when a health bar changes. Okay, now the other challenge is that games need menu screens and inventory screens and things like that. How do you do user interface? How do I take my user interface from my PC game, bring it to my tablet? And there's a variety of technologies. You can just write it yourself in Direct3D, which is what, believe it or not, most games on the PC today do. Some of them use Scaleform, which is really layered on top of Direct3D. It's a third-party component provided by Autodesk. And Direct2D can actually make some of that easier, and then XAML, of course, can be used if you want to go forward with that. And one of the tricks is you can create separate framework views within the same window so that you're using XAML in one of them and D3D in the other, and that way you can switch back and forth very efficiently. But one of the new features that's added in 8.1 is the ability for you to create a second window within your application that is split screen. And the nice thing about that is that you can treat it as a completely separate window. It can have its own message pump, effectively its own event stack, and its own rendering model. But you can switch back and forth using the activate and the query activation events. And the nice thing about it is that you get that standard user interface model of the splitter bar that everybody's used to for managing split screen content in the OS. So that's an example of my store app and my games app in 8.1 being simultaneously split there. That's the user interface anyway, what it looks like. And the thing is, in this screenshot, I'm actually showing two separate applications, and you can do that too. Some games that are out there today will have their settings and options, and they may have their own in-app purchase store that's a separate actual application, and that application may be written in HTML, even though the core game may be in Direct3D. So you still have the ability to launch that application using our new APIs in Windows 8.1 that will allow other applications to launch each other in an efficient way. And the nice thing about that is you can control the lifetime of these applications independently, and you can use different languages, for example. But you still get the same user interface as far as the user being able to adjust the split between the two. And there was a nice talk on that already this week as well. Okay, one of the tricks, though, you keep in mind there is that just like you do on Windows today, you do have to pay some attention to focus management, particularly when you're running a 3D game and you want the user to be able to switch over to work in the App Store so they can purchase something for that game. You don't want the 3D game to steal so much of the machine's resources that they can't work your store. So in many cases, you need to recognize when that's happening, throttle back the frame rate, switch to a different event model like we showed in Matt's talk the other day, and that way the application pane that the user is actually working on will get the majority of the resources in the machine. And there's other things to check for as well. If you bring up your App Store on top of your main game, so it's fully occluded, then you can just stop rendering the main game completely. And these are all trackable via the visibility changed and the activation state changed events in the Core Window API for sure. For example, this is the case where we're checking occlusion. I actually queried the window state based on the visibility changed event in a separate event handler, and then based on that, we switch between the sort of in-focus model that you see at the top, where everything's rendering as fast as it can, versus this sort of suspended model where we're just waiting there for the events that will tell us to start back up again. And that way, other applications can still run the machine pretty well. Okay, another common use of the high-end games that we see today is a lot of them will support multiple monitors. And as of Windows 8.1, we've added that technology to our new API set platform so that you could, for example, take your tablet and dock it to, connect it to a monitor for a cable, or potentially project it to a remote TV, and then the same options are now available to these handheld devices as the desktop PCs have had. The interesting scenario here is when you're in the living room and you're leaned back, you're looking at your tablet, but there's somebody else there and they want to see what you're doing, you want to show them what you're doing, you could project that out onto your TV. So there's a new technology that's coming from the hardware vendors. The brand, I think, is Miracast, but it's a wireless display technology that a lot of the tablets will be supporting here in the next, this year and next. And that's really based on this Wi-Fi Direct technology, which we just saw in the previous talk. But it's a very low-level wireless solution based on the same antenna that your Wi-Fi chips already use, but it uses a different protocol that means you don't have to actually join the wireless access point and type in the password and all those things just to project your display up there. You can pretty much flick your display up to your TV once it's been paired. And that's great for cases where you want to put a secondary monitor. Like if you've got multiple people playing a racing game, they could put the map up at the top or the leaderboard, or you could put like your Monopoly board or your Scrabble board on the TV, and then each person's tablet is their own set of cards in poker or a set of chips in Scrabble. And the API support for this is pretty much nothing. The system would just go into multi-pawn mode. The user could flick that in through the charms and flick it up there, and then it works without API support. But if you want to actually have more control over which applications, which content of your application shows up on that monitor, there's a new set of APIs that have been added in Windows 8.1 as part of the Projection Manager object that are used to allow you to control a specific window that goes up on there. And you need that if you're going to put something different on the TV than what you have on your own device. And then there's one other area that's really common in the PC games today, and that is networking. The scenario that the obvious ones are any type of device is going to want the ability to save state between machines. So if I'm playing a game on my PC in the den and my wife comes in and says, I've got to do the taxes, I let her have the machine, I go in the living room and I pick up my tablet and I can pick up where I left off if the application is supporting that sort of remote cloud-based capability, which there's some support in the APIs in the Windows Runtime API set around roaming state, but also there's Azure, which you can use to actually store significant amounts of data, like save games up there. And the nice thing about that is if you use a lot of these low-level APIs, for example, are very consistent across the other Microsoft platforms, which means that you could theoretically, I mean, we've demonstrated this a few times at GDC, make that transition work so that even if I get kicked off on my couch and I have to go out and I'm on the car somewhere, or I'm on the bus, then I can use my phone to continue the same game. But the other interesting scenario is this is one of the other advantages of the high-end PC aspect of this, is that developers have created a lot of content for the PC up till now that is multiplayer. And I know a lot of people assume, okay, multiplayer means, I guess a letter and 3 million people elsewhere in the world guess the letter, and then we find out if that was the same letter. That's a type of multiplayer, but it's sort of the one that people have had to use with phones because, when you've got your phone, you don't necessarily have other people that you want to play with you at the time, right? You're on the bus, you're in the line at the grocery store. But the PC scenario has been where people would come over and they would do LAN parties and they would play games against each other. And that was kind of a challenge when your PC that you wanted to take to the LAN party weighed 40 pounds. But now that you can do this with a tablet, people will come over and they'll bring theirs and they'll sit next to you across from the coffee table and you can play poker or Scrabble or something. And again, with this wireless, you can hook up the TV as well. But the thing I want to make a distinction on is this difference between what people have been assuming that all a tablet is capable of is things that like you could do on a phone. And our position is that a tablet PC is still a PC, and it can do everything that a PC used to be able to do, including multiplayer synchronous gaming, in which two people that are actually in the same room at the same time talking to each other head-to-head can have an interactive, cooperative, or competitive experience. And that's what we call asynchronous multiplayer versus synchronous multiplayer. So there's no reason to not have your tablet also do everything a phone does, because it's certainly powerful enough, but then it can also do everything a PC does because it can play the synchronous games as well. Now, there is some amount of variation in terms of the types of games. If you're sitting on the couch with your wife across the coffee table, you're probably not going to be playing Deathmatch Fragfest, but that's really just more of a question of what types of mix of titles you want to have available. And I don't think there's anybody who says they don't ever want to see some particular title in some particular scenario, right? So as more and more of these devices are coming, they're getting increasingly connected. The performance of Wi-Fi AC is coming out there. There's more and more 4G and 3G and LTE technologies coming out. You do have to. So this is all going to become more and more common. Our new store packaging trick actually helps you with the download and install. A lot of these places or stores will have a limit, or service providers will have a limit on how big of a package you can buy and have it install if you're on 3G as opposed to Wi-Fi. And by using that solution we talked about, you can get your package size to be much smaller and increase the number of times that a user is going to be able to play it immediately after purchase versus having to wait till they get to a Wi-Fi connection. And then there's this whole spectrum of new scenarios that range from the ones commonly seen on tablets and phones all the way up to the ones commonly seen on PCs. And there's relatively minimal impact on the API, the gameplay design that you need in those cases. Okay, now, if I'm going to take my code and I'm going to run it on a tablet, I'm going to run it on a laptop, I'm going to run it on a desktop, it's still interesting to organize the code in such a way that the pieces that are optimized for the hardware are isolated from the pieces that are part of what the enterprise people call business logic. That's core gameplay that can be consistent across all your devices. And just organizing things into C++, DLLs, or libraries is a really good way to manage that. And then the other thing I want to point out is that not only are our APIs designed to enable these applications to span these different ranges of devices, but our tool story is as well. And so the Visual Studio is the foundation for the development and the core language that spans all these devices, whether it's on the desktop, the Windows Store applications, Windows Phone applications, or the consoles. And then, of course, we've actually improved in Windows 8.1 the high-end debugging techniques that you need to make these applications even easier to write. So there's a whole spectrum of talks that have been given here today. I think there's one more later this afternoon on the new C++ CX language right after this one, which I'm going to go to. It's basically how to get the performance of C++ with the syntactic simplicity of something closer to C#. Okay, so in summary, what I'd like to convey here is that we're very interested in having games that span the whole range of PCs that are available today, from the 8-inch device that you received all the way up to the 3 GPU SLI rigs. We're not putting any barriers anywhere in that spectrum that would prevent you from distributing your content however you want to across that range. And these are just an example of some of the improvements that we made in Windows 8. In the new APIs for the Windows Store, we've made sure that the latest Direct3D was there. We put our best audio API there. Pointer Point is the one that helps you manage touch, mouse, and stylus all consistently. But then we actually went in and added specific support for mouse look, for first-person shooter style mouse look WASD controls to the modern platform when we released last year. And then, of course, Xinput is our game controller API. And then, of course, we made some additional investments in C++ as a language to make sure that the portions of your code that you want to optimize in C++ would be very fast. And then in 8.1, a mere 12 months later, we doubled down on this investment with a significant stack of new capabilities that make this scenario even easier. So we added a new version of Direct3D 11 with a significant number of additional features, tiled resources, most advanced technology anywhere today. Scalars and overlays help with this performance of tablets. And then we actually improved our compiler and linker technologies, put them inside the system folder, and then added this linking technology that makes it much easier to manage your HLSL code. We upgraded the package size from 2 to 8 to 25 gigs, depending on how you structure it, and then added support for Multimon and Wi-Fi Direct for network gameplay, which is a kind of ad hoc gameplay that like you would find in a handheld gaming system. So in summary, we didn't put any barriers in place, so you guys should be totally unblocked to move your content from a very high-end application onto the broadest number of PCs that are available out there today. So check out the solutions that we've got, and good luck. Thanks a lot. And of course, that's the review code. So if anybody has a few quick questions, we've got a couple minutes left. Yep. The question is what happens with the resource package when you upgrade the machine. One of the things that's been added in Windows 8.1 is the fact that your applications are dynamically updated in the background. So the user cannot even know when they upgrade, they stick a new graphics card in their machine, they can get the bits depending on whether the OS has decided to upgrade that or not. And if the OS hasn't had a chance to do that, they can always go and reinstall the application and they'll get the full range of bits available. Any other questions? Okay, the one over here. I didn't hear the first part.
So you have different 3D cards.
Yeah.
So a tablet will have a very small 3D card versus a desktop.
Yeah, the question is how we handle the differences between graphics cards, and there's, like I said, there's two main types of differences between graphics cards. One is the feature level, which is DX9 versus DX10 versus DX11, and the other is the brand of vendor, and then I guess the other one is the performance bar. And so the API runs across all the different feature levels. You can select that setting. It already runs across all of the different vendors in each generation, just with no code change at all. And then the final question is the performance, and that's where we're saying you may have to render at a lower resolution on a lower power device and let the hardware stretch it back up. Okay, that's all we've got for the public questions, but you can ask, just it won't be on the tape probably. Yep. So the question is about Wi-Fi and whether you get that for free with existing tablets. And the answer is you do, because all of the Windows 8 and 8.1 low-power devices have the type of Wi-Fi chip that is capable of doing that. The challenge is they may not all have a sufficiently recently installed driver. And the other challenge is that your I think there may have already shipped some receivers that aren't compatible with that and would also need a driver upgrade. So we're within some software changes of pretty much having everything work. And it's just going to be a question of time for how long it takes those drivers to get upgraded. Okay, come on up and ask if you have any other questions.